4.7 is about the quadratic formula. This is just yet another tool for solving quadratics that works every time. And this, I argue, is by far the best one because, like I just said, it works every single time. Factoring, completing the square, whatever other ways we go through aren't going to work every time. Quadratic formula works every time. So if I'm looking at this, let's go ahead and do it. First things first, let's subtract the 4. All quadratics have to equal 0. 2x squared minus x minus 4 equals 0. There's your a, middle term's your b, last term's your c. So you end up with negative of negative 1 plus or minus the square root of b squared minus 4 times a times c, which is negative 4, all over 2 times a. Now, what's nice is this kind of calculator work. The negative of negative 1 is positive 1, plus or minus. Plug all that in your calculator, square root of 33, all over 4. And again, use the parentheses where appropriate. That's why I plug them in using the parentheses. And that's your answer. Remember, there's two solutions there. Plus or minus count as 2. One plus square root of 33, one minus the square root of 33 over 4 are both solutions. The discriminant is kind of nice. You've got to do this anyways when you're doing the quadratic formula. So when might as well start at that point in time and just get that number, because that leads me to what is going to happen with this particular function. If the discriminant is greater than 0, you're going to have 2 real roots. If it equals 0, you're going to have 1 real root. And if it's less than 0, you're going to have no real roots. And we'll talk about what you're going to do with that later, but that's not a bad way to start. So let's go ahead and do this. It's b squared, so negative 3 squared, minus 4 times a, which is negative 2, times c, which is 5. And again, this is just plugging it in. You're not taking the square root here. You're just trying to find out what number is underneath that square root. When I plug in my calculator, that gives me 49 as my answer. And since it's 49, that's greater than 0, so we have 2 real roots.